Okay, today we're going to talk about ellipses. This is out of section 6.2 in your book, Ellipses and Hyperbolas. We're just doing the ellipses today, and the mathematical definition of what an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. And each fixed point in that is called the focus of the ellipse. So ellipses have two focus points. A circle just has one focus point. So that's really the difference between circles and ellipses. If we move these focus points right together, it ellipse becomes a circle. Okay, so we have two little vocabulary here. The longer way, the ellipses are longer one way than the other. In this case, this one is longer on the x numbers. The x-axis is longer than the y-axis. So the major axis is stretched out horizontally. The minor axis is stretched out vertically. The coordinates of those axes are, we use A for the major axis, we use B for the minor axis always, and the C goes with the coordinates of the focus points. Okay, so the from A from the, here to Z, from the origin to one of the vertices, these 4 points are called the vertices of the ellipse. So it has 4 vertices, one at A, positive B, and negative B. In all the X's, the A's goes with the X's, the B's go with the Y's. And well, I shouldn't have said that. That's for this one it does. And the A's always go with the longer one. So sometimes the A value is actually, vertical and not horizontal like it is in this one. So it's not, the A's are not always associated with the X values. The A's are associated with the longest axis, whether that axis is horizontal like this or sometimes vertically. Okay, so the sum of the distances from the foci to a point xy on the ellipse is 2a. So the sum of these distances, we go from one focus point to a point P and then point P to another focus point. The sum of those two distances is always going to be 2a. And you can kind of get a feel for that if you put a point here at one of the vertices. So from here to here is a plus a little more, and that little more is what's left of A. So A is from, the vertice to the focus point over here to A. So the sum of of the um, the distance that we're talking about here on these ellipses, that constant distance is 2A. And the two equations that go with the ellipses look a lot like the circles, right? They have x squared plus y squared, but instead of equaling a radius squared, they equal 1. So I always have this in the standard form, always equals 1. And the a squared and the b squareds go underneath the x or the y. Now don't get, the a's and the b's are what change places in these formulas, or I guess they change it, the y squared and the x squared change places. But the a squared is associated with the major axis, the longer axis, and the b squared is associated with the smaller axis. So on the top one here, this is going to be an ellipse that is longer horizontally than it is vertically, and on the bottom one, this is going to be an ellipse that's longer vertically than it is horizontally. Okay, so those are not great ellipses, but you get the idea. And A is always greater than B. Okay, so A is always greater than B on both of these equations. And the other relationship between C, A, and B is this. C squared equals A squared minus B squared. And that's the same whether the ellipse is as a major vertical axis or a major horizontal axis. The same relationship holds true. Okay, so you're going to have problems like this where you need to graph an ellipse. Okay, so how do you start these problems? Well, we wanted to get it to look like this, we wanted to get it to look like this, where the equals 1. We wanted to get it to, x squared plus y squared over some a and b squared equals 1. So the first step here is we want it to equal to 1, so we have to divide everything by 36. Okay, so when we do that, it looks like this. So that's very similar, a nice form for it. Okay, so x squared over 9 squared and y squared over 4. Okay, so we know that this one, if this is the 9 is going to equal the a squared, and this is going to equal the b squared. 4 is going to equal b squared. Okay, so this one is going to be longer horizontally than it is vertically. So the major axis is going to be a horizontal axis. And the ellipse is centered at the origin. We're just doing one centered at the origin now. And the graph of it looks like this. Okay, so these are the 4 vertices we have. 3, -3, 2, -2. The vertices centered at the origin. Okay, we also talked about focus points. So what about the focus points for this graph? Well, we start out changing it, dividing everything by 36. How are we going to figure out what the focus points are? Well, we have to use those relationships that c squared equals a squared minus b squared. And we know the 9 is the bigger one, so that's going to equal a squared. And the smaller one is going to equal b squared. So we plug those numbers in here. The 9, the a squared and the b squared is 9 and 4 equals 5. So c equals plus or minus 5, plus or minus the square root of 5. So the focus points are always along the major axis, right? So the major axis on this one, 1, 2, 3, 1, 2, 3, and 1, 2, 1, 2. Okay, that's not a very good ellipse. Okay, try that one more time. I'm just going to draw it out. Okay, so that's 3, -3, 3, 2, -2. So my points of my focus are always going to be along this major axis. So there's going to be square root of 5, negative square root of 5. And it's going to, if I was going to write it out, with the 0 here, because it's this one's centered at the origin. Okay, find the equation of the ellipse having a center at the origin and 2 focus points at positive and -3. And the major axis is 8 units. Give the domain and range. Okay, so the first thing I would do on this one is draw a little sketch of where the heck these things are. Where are my focus points? Okay, so I know my focus points are going to be on my major axes. And so where is the focus points at? At 0, +3, 1, 2, 3. So I'm going to have one focus point there, and the other one's 1, 2, 3, going to be down here. Okay, so my 2 focus points are there. So I know this is going to have one where the vertical, it's going to have a vertical axis is going to be the major axis. And the major axis is 8 units in length. Okay, so that's from vertex to vertex. The positive to the negative vertex is 8. So how does that help us? Well, we know that the major axis is equal to 2a. So 2a is going to equal 8, so a is going to equal 4. So to put in the vertices here, I put in one more. There'd be a vertice there and a vertice there. Okay? So how about the other stuff? I'm going to get the equation of ellipse having the center at the origin and that. So I've got my a, right? This is my c, this focus point here, since it's centered at the origin, that's going to be c is going to equal 3, right? The center to the focus point, that distance is c. Okay, so that's how I got the c there. So I have a, I have c, I need to find b. So how do I do that? Use that relationship, a squared minus b squared equals c squared. Okay, so I plug in what I have here, and I get 16 minus 9 equals 7, right? This is a squared, and this is minus c squared equals b squared if I, rearrange everything. So b squared is going to equal 7. So that means b is going to actually equal the square root of 7. So the foci lie on the x-axis, the y-axis, so that's going to mean that my a and b are going to look like this. My equation is going to look like this. The a is going to go with the y because that's bigger. The major axis goes with the one that is horizontal, so that's why I'm going to put the a squared there, and the b squared is going to go with the 7. Okay, so I've got my axis, my equation, and the domain. Okay, so my domain is the x number, so I go out here, and the square root of 7 is about, it's a little more than 2, square root of 7, square root of 7. So this ellipse goes to 4, square root of 7, down to 4, up like that. So it kind of look like a football, but hey, Super Bowl. Okay, so that's the equation here. The y, the a, the bigger number goes under the y this time because we have a vertical ellipse. The longer axis is vertical, so the a squared is going to go underneath the y squared. The b squared is going to go underneath the x squared. Because now we have to talk about when we have the vertices of the, or the center of the ellipse off from the origin. Okay, so it's the same thing we've done on the parabolas and the circles. The circles h and k are center of our ellipse this time. Okay, so the equation looks very similar except we have minus h and minus k for y. And the a and the b, the same relationships go. The a is always bigger than b. The a is going to go with the major axis, the b with the minor axis. Okay, so we want to graph this one. Okay, so first off, we have to figure out where is the center at. Okay, so this is my h, and that's my k. So the center is going to be, I draw a little axis here, my center is going to be at 2, -1. Okay, so I go over 1, 2, and go down 1. So that's my center. Okay, so what else do I know about this? I know that the bigger one is a squared. It's something, they've written it on the left, but this time they wrote it on the right, and it doesn't really matter. So the bigger denominator, whichever one it is, that's going to be my a squared. Okay, so it says underneath the y numbers here, the y squared, I know it's going to have a the vertical axis is going to be longer than the horizontal axis. So how long a is going to equal, so this means 4 equals a, so I need to go up 4 to put the other vertices on. So I go up 1, 2, 3, 4. So that vertex is going to be at 2, 3. The other vertex is going to be at down 1, 2, 3, 4. So that's going to be down here at 2, -5. Remember the center was at 2, -1. Okay, so my b value is, b is going to equal 3. So I go over plus or minus 3. So I go over 1, 2, 3. Oops, 1, 2, 3 would be here at, I kind of got that in the way, would be at 5, -1. And I go back over here, 1, 2, 3 would be at -1, -1. So my ellipse would go from here, go through the start here, go through the -1, around like that. So it's going to look pretty circle-like because the A and the B are not that much difference between them. And the center here, let me get rid of my ink here because I'm going to put it up in nice. Didn't clear. Oh well. Get rid of all this. Okay, so this is what the nice graph looks like here. And okay, so it centers at -2, -1, and we know it's going to be higher vertically, and it goes through 2, 1, so we know that's the major axis is going to be longer vertically than it is horizontally. If you want to graph it on your calculator, you have to kind of graph it. The calculator only does the y equals, so you kind of have to do this manipulation around. I don't know how useful that is. It's probably just as faster and easier just to do a quick sketch with by hand to really get what's going on here. So do one more example here. Let me that's not what I wanted to do. I'm going to erase all this stuff. Okay. So we have a problem like this one. We have the equation for ellipse. We have these vertices and we have these focus points. Okay, so we have the two vertices and two focus points. So the first thing you need to do is draw a quick sketch and see where everything ends up. Okay, so draw a quick sketch and 16,6. I'll just say this is 16 and this is 6. 16,6 would be one vertice is going to be up here. Okay, so that's one vertice. Negative 10,6, I made that probably about here, negative 10 up at 6. Okay, so that's my other vertices. And my focus point is going to be at 8, 6. So I go over like halfway here, and that's 8 up to 6. So that's one focus point. And the other one's at negative 2, 6. So that's going to be right about there. So my other focus point is at here. This is negative 2 up at 6. So I can see that this is going to be a ellipse where the horizontal axis is going to be the major axis. Okay, so the general form of the equation then is going to look like x minus h squared, and that's going to be over a squared because I know that the vertical axis, the horizontal is going to be longer because the focus points are on that, plus y minus k squared over b squared equals 1. Okay, so now my job is to figure out a squared, b squared from what the information I have here. Okay, so from this point over here, a squared is, the center is obviously in here somewhere. So maybe I figure out the center of this. So the center is going to be halfway between these two focus points. So the one focus point is at 8, the other is at negative 2. So that's a difference of 10. So halfway between 10 would be 5. So this would be at 3. So the center is going to be at 3, 6 is my center. Okay? And what's my A value going to be? My A value is going to be from the center over here. That's going to be one of my A values. From here to here, from 3 to 16 is how long? It's 13. Okay, so that's 13 equals A. If I go the other way, it should be from 3 to negative 10 is also 13. Okay, so I don't know anything about the B values from this one. I can't really, they gave me the focus points and stuff to help me find the center. So I got the center, I got the A, but I don't have the B. So I'm going to have to use that relationship we had before, that C squared equals A squared minus B squared. So that's going to lead us to, we know what C squared is. C is going to be how big? Well, maybe we don't know what C is. Yeah, we know what C is. C went from here to here. Halfway was 5, right? Halfway was 5. So C is going to equal 5. Okay, so I have 5 squared equals, and we know A is 13. 13 squared minus B squared. Okay, so if we move this around, work our algebra magic on it, you get B squared equals, I'm just going to multiply them out, 169 minus 25, right, with a B, and that's going to equal 144. So now I have everything. I have the B squared, I have A, so I can start substituting stuff in here. Okay, so A squared is what? If A is 144, A is 13, then A squared has to be A squared equals 13 squared equals 169. Similar for the B I already know what b squared is, so I didn't even change it. B squared is 144. And my h and k, my h is, what's my h? That's my, the, this number, it's 6. And my k goes with the x number, that's going to be 3. Okay, so my equation for the circle from this is going to, I'll erase this part here. It's going to look like this. X minus 3 squared over 169 plus y minus 6 squared over 144 equals 1. Okay, so that's my equation of the circle for a parabola when you know the vertices and focus points. Okay, so stop the video and see you in class tomorrow. Good luck.